Okay, great. Okay, great. So, hi Rahila, hi Alvin, hi Hung, hi Shahida, hi April, hi Sunny, hi Prashun, hi everyone. So, let's start. Shamit, are you able to hear me now? I guess not. Yes, please, Shani, go ahead. Okay, before we continue our discussion from data model, I would love to answer your questions. Okay, a question from Sunny is, when we upload a file on a local file system, okay, what do you mean by that? Why cannot we see the HDFS files? Cannot the HDFS see the files which are stored in local file system? Okay, yeah, let me try to understand it again. Um, okay, yes, please feel free to rephrase it. Okay, okay, good, good that Sanjana you have asked. Okay, all right. Uh, let me take this question on the notepad. Okay, so here is the question from Sanjana. A question is, a question is, when we said create, okay, when we said create my slash, what was the, I think 14 Jan slash my node, and then we provided some data here. Question is, what does this data mean? So just like you have a file name and there is a data inside the file, similarly, a node has a name, okay? A node has a name and the data inside the name, inside the URL, okay? All right. This is the data. Now, another question that arises is, what is there? What is the format of this data? Okay. So I'll give you a proper example, I think. Yes. So whenever we are storing data somewhere, we need a reference, basically a name and the content, right? And that's what it is. Name of the node, name of the node, name of the node, and the data inside it. Okay. And all right, let me just SSH. Okay. So when we say zookeeper, okay, I'll give you a little bit more background. I hope our session is being recorded properly. Yes. Okay. So what you see here is when I say create this, right? There is a URL of this and the data inside this. Okay. So what's the use of it? You might ask. Okay. So it's like saying name, key and value. You remember registries? in registry, you have the name of the registry key, and there is a value for each key. Okay. All right. So let us say that everybody is trying to inform Zookeeper that we have created a node. Okay. And we want some extra data to be kept inside it. That data goes into this value. Okay. Now, another question that is generally asked is, what can we store inside it? In what format do we need to store? Like, for example, if I try to store this, okay, it would give an error. I'll show you. Okay. It says it, it is not in this format. Okay. So we can store this in the form of something called JSON. Okay, something called JSON. A JSON is a very good format to represent complex data. Okay, so you can see that we have been able to store data in the form of JSON, but not in the form of simply any data. Okay, did I make sense to all? So this format is called JSON format. It's called JavaScript script object notation. Okay. All right. Who else does not know about JSON? I'll try to see if there are many people who don't know. Okay. All right. All right. Okay. Okay. So 1, 2, 3, 4. 4 people. Uh, who else? Yeah. So others know about JSON. So JSON is a very nice way of representing data, and it started with JavaScript. Okay. So let's say you want to represent somebody's name, so you can put something in the double quotes, or okay, like this. So Sandeep is a valid JSON data, and then a number is also, but it should be in double quote. Number is also valid. Let's say you want to represent the complex detail of an object, for example, a customer, right? So whether you put it comma separated, colon separated, there are so many confusions and complexities. And that's where these formats come into play. So let's say you want to store a customer's object. So you could say name, colon, Sandeep, okay? And you could say address, colon. It's just a format so that it's a standardized way of representing complex data, okay? Okay. And let's say we want to add some more things here, like um, uh, movies, the movies the person watches. Okay, it could be further an array of values. Okay, so we basically okay, B for van data, and then something like this. All right. So you can see that it is a very generic way of representing data. All right. Because if you remember, comma separated values, you will face different kind of difficulties. One, you cannot represent row which contains more rows and more values inside it, right? Or each cell, if it is having further more values, then you cannot really represent that in the form of CSV. CSV does not provide the arrangement for it. Okay, that's where the complex objects like this come into play. Okay, and let's say what else we could have? We could have purchases here. Okay. The purchases could be further array of objects, and this array of object could be another like complex object, and so on. This is JSON. Okay. Further, the object purchases is like item ID. Okay. And item ID, and we could say something like this, and price. Okay, and so on. So you can see that we are able to represent a complex object in the form of a string, plain text string. Okay, so JSON is something like you can always think of JSON as a replacement of XML. Okay, so those who are familiar with XML, they can correlate that they could represent a similar complex object using XML. Just that in XML, the data takes more space because you have to define starting of the node, ending of the node, and so on. All right. Now, different languages have different JSON API. Using that, you can convert a string of JSON into a complex object, and then you can walk through the object. You could say, give me the children of this node, give me the values, and so on. Every language has inbuilt JavaScript, JavaScript parser. Yes. So it's basically a format. It's a universal format in which you can represent complex objects within objects, and array of objects, and so on. Okay, you can represent that uh, in the form of JSON, and this JSON is kind of a string which you can parse it, and then you can convert this into object using a API or a library function. Okay, so JSON is used by many NoSQL databases such as MongoDB and CouchDB. So you store the values in the form of JSON. Just give me a second. Hello. Extremely sorry, I cannot turn off the phone, and yeah. All right. So I hope was I able to make it clear what does it mean by JSON? JSON will be used in future as well. Okay, that's why I took some time to explain what does it mean by JSON. Okay, good. Let's move on. There are a few more questions, and then, all right. Now, let me go over Sunny's question. So Sunny says that, let me ask you properly. I am downloading a file called file1.txt. Okay. and wget this. Okay, we can see the file when we type ls, but when we type this, correct. This is, yeah. So I hope, okay. Okay, now let's see. All right. So does anybody else have similar question? Okay, let me try to explain once more. Yes, go ahead with the question, Sunny. Okay. Okay. So basically, Sunny, there are three folder structure, or you can say file systems. One is your laptop, all right? One is your laptop. Second is console. Okay, the console as in the Linux machine, say E or F or G. Okay, and third file system is HDFS. Okay, where the information about the file system, like folders and file names and all, is stored in name node, and the actual data is distributed. Okay, now the question is that when we download something, right? So when you say wget here, you are downloading the data from internet. Okay, so the file is being created on this machine, correct? File is being created on this console machine because this is a physical computer. Your laptop is a physical computer, while HDFS is basically name node. Name node as in because we interact with name node. Okay. So here we have, and now from here to HDFS, we will need to move this command manually. Okay, because this is a different computer and different file system. This is different, right? That's why when you say ls here, uh, when you say ls, you see the command, you see the files. But since this file, which you have wgetted right now using wget, okay? So I'm saying this is internet. This is, I'm really pathetic at writing. So this is internet, and from internet you have downloaded a file. Let's call it ile.txt, right? So, right, that's why when you want to, from this machine, if you want to interact with HDFS, you will have to use Hadoop FS. Okay, you'll have to use Hadoop FS. Okay, make sense, Sunny? Right? So this file, if we want to upload it there, then we have to say copy from local. This is your local because this is where you're logged in. When you execute some command, it's going to impact this machine. Therefore, this is your local. And when you say Hadoop FS copy from local, it goes into HDFS from here. It copies from HDFS, from local to HDFS. Okay. Right? From here to your console, you can upload using, say, FileZilla, okay, FileZilla or SCP. While to from here to here, you can use Hue, okay. All right. So yes. So try experimenting with these, in all three ways, all of you, because it could get confusing if you do not try it. Okay. Once you try it and you get stuck with things like, okay, I just copied files, but I don't know where it went. So you will go and check all the places, all the three places. This one in Hue, then this one using console, ls, and then this one is your laptop. And then you'll figure out, okay, I actually did this. Okay. So if you don't try, it'll become confusing, and it'll be because more than one place in file system, it is always more confusing. Okay. Now, there's a question from Ravi. Okay. Um, in global view of HDFS, I think is only limited to what data nodes are in Hadoop system. I think client machines are not known to Hadoop, so it's not, they are not part of HDFS global view. Yes, you can say it that way. Client machines, basically, client machines file system is not directly represented in HDFS. Instead, HDFS creates its own folder structures on every data node, as we saw last time. Okay. All right. Wonderful. A question from Sudhakar. Okay. All right. So this is okay, and I'm going to move back to yes. A question from Sudhakar. What is the driver to create number of Z nodes? Is it based on number client connection expected? Will each client request assigned to a Z node? So here, a Z node does not mean a machine. It just means a file. Okay. So yeah, that is a little confusing because we always talk about data node, name node. So they sound like they are services or machines. But here, Znode basically means a file or a data holder where we put the data. Okay, a Znode is just a place where we put the data. Okay. When we change the replication factor of an existing file, will those existing blocks be deleted first? Okay, so let me confirm if Sudhakar, did I make sense to you? Okay, so yeah, please feel free to clarify. So yes, there are nodes in Zookeeper. I will discuss those nodes again, just like we have name node, data node. But here, the Z node does not mean the services. Z node is just it's a very I would say if I am somebody designing Zookeeper, I will not call it Z node because I face a lot of difficulty explaining that Z node is just a place of storage. Like you have in registry, we call it key in the registry in Windows. Similarly, we have Znode. Okay, so please feel free to explain to me what exactly I meant to say. You meant to ask. Okay. Srini's question is, but what tells Zookeeper that how many Z nodes should be created? Is it similar to some config settings? So a number of Z nodes meaning. So right now, if you take a look at what we did, these all nodes are created by the customers. Okay, we are telling Z node that create this node, create that node, and create Z nodes. Not let's not say node. We'll call it G node specifically. It's basically folders in the file system. Okay, you can think of it like folders or files in a file system. Okay, these are G nodes. 8 October, IBM. So all of you have created one Z node, like 14 Jan. Okay, so these were the Z nodes that all of you have created. And 14 Gen is one Z node that I created. Yes, it is up to the team to decide how many they want. Yes, it's up to us, up to our architecture. Okay. Okay, these are very valid questions, and most of the confusion is generally in the taxonomy, as in the is basically in the the terminology. Okay, yes, please. Yes, it's a little confusing between Yarn and Zookeeper. Zookeeper, we will talk about their nodes. We will talk about the machines under the hood. But right now, a Z node is basically part of the data that we are trying to store. Yes. All right. Sudhakar, is it possible to rephrase if I can understand the question, maybe different words? This data is like database, like a central place we are writing data to. Okay, and this data is created by clients requests. Okay, and clients of Zookeeper are all kinds of systems. You can see here there are these brokers, right? And you'll be amazed that this is created by, you know who? Kafka queue. Kafka is another system. Similarly, I'll show you some more things. And this, you can see there'll be HDFS somewhere, like Hive server. You see Hive server? This Z node is created by Hive server. So Hive server is also connected to Zookeeper, and is basically, because we have multiple Hive machines, so they're communicating with each other via by creating these data holders. Okay. Okay. A question from Sudhakar is, when will this data get deleted? When you want to delete it. Okay. All right. Can you let me come back in a minute. Hi, I'm back. So yeah, I'm extremely sorry for that. All right. All right. So I was getting some calls, so I was answering to those. All right. So yes. All right. And uh, okay. A question from Sudhakar is that is this a dedicated Hive server until a G node is deleted? Yes, I'm going to cover that part in a minute, Sudhakar. It's a good one. All right. It's a good question. Okay. So these G nodes are local to specific servers? No, actually these are central. Just like you have database in which you write data and you can access from everywhere. In the same way, these G nodes or these folders are basically centralized. All right, wonderful, wonderful. And moving ahead, great. So we have already covered these parts. All right, next is so far we have talked about only one kind of a Z node called persistent. As there was a question from Sudhakar, for how long this node Z node will be there in the database in Zookeeper. Okay, so the persistent remains there unless deleted by someone. Okay. Second is ephemeral. Ephemeral is something very interesting, something which we have not seen in past. We have not seen in past that we created a data and it disappears by itself. Okay, so ephemeral node is a very interesting concept, which essentially, uh, uh, you know, the node, the data that we create disappears. Okay, as soon as the session that created an ephemeral node that disconnects or that exits. Okay, for example, you can create an ephemeral node by saying create minus e. Earlier we did not provide any switch. Earlier we did not provide any option like minus e. So by default, every G node is an persistent by nature. Every G node is persistent by nature by default. But if you want to create some node that you want to disappear as soon as session disconnects, or you, I mean, you have logged out. So as soon as the session disconnects, this node will disappear. Okay, so like what you see in the right hand side, the list of participants, right? We have all the participants right now. As soon as any of the participant exits from the session, this Zoom session, the name will disappear from participants, right? In the same way, you can think of the list of participants to be containing ephemeral G node. Each individual's attendance is ephemeral Z node. As soon as somebody would exit, their name from this list will disappear. That is exactly the role of ephemeral. Okay, so as you can guess, the ephemeral node can be utilized as kind of attendance marking system. Who is up, who is alive, or who has disconnected or dead. Okay, so Ephemeral Z nodes are quite useful, as you can envision that in the HDFS kind of a case where name node needs to track whether a data node is dead or it's up or it's down and so on, right? A clever thing would be that let all the data nodes inform inform Zookeeper by creating ephemeral nodes, okay? And as soon as one of those data nodes go down, the ephemeral node here would disappear. Ephemeral Z node that they created to mark their attendance will disappear. All right, I'll show you something. So let's say I am right now in this session, okay? I'm going to create an ephemeral node in the same one, 14gen slash sgeph, okay? This, okay? Again, I'm just writing some data, okay? So this has been created as ephemeral node. If you want to check whether a Z node is ephemeral or not, you can say get. It will show you the detail, including data and the ID. Every Z node has an ID, and created time, modified time, and so on. All right. Now, how do you identify whether a particular Z node is ephemeral or not? In case it's an ephemeral, then ephemeral owner will be non-zero. Okay. Otherwise, it'll be zero. Otherwise, it'll be uh, you know, it'll be, as you can see, I must have done get here. You see, ephemeral node in this particular ephemeral owner in this particular node was zero. Okay, while it's non-zero in this case. Okay, so this is how you identify an ephemeral node. Now let's try to do an experiment. Okay, or let me try to create a particular node. First, I'll create inside 14th gen. Okay, and I will create what's the date today? Today is 28th Jan, and I'll say the data inside it is attendance. Okay, now this is a non-ephemeral node. So in this, I'll create 14 Jan slash 28 Jan. Inside this, I'm going to create my own okay, ephemeral node. Okay, I'm going to create my own ephemeral node. Yes, in this folder, I have created an ephemeral node, or you can say in this path, I have created an ephemeral node. All right, good. All of you can also see that that it has been created. Now, for some reason, if I disconnect, I just did Control D, and also I disconnected from console itself. If my internet goes down, or I exit from Zookeeper, or I close my SSH console, or something happens, then the session will end. And if I go back after a few seconds, the data would disappear. Okay, you can see the Z node has disappeared. Is it clear? Yes. So we created a Z node which got deleted because we exited from the server. Okay, we created this particular one with minus E. Sorry, we created SG with minus E. This one we created without. Minus E means ephemeral, means it will disappear after you exit. Okay, I'll show you. Let me scroll up. So you can see, first I created a persistent node called 28gen. Then I created an ephemeral node with SG, which was there when I did this. It was there, and then I exited and connected again. Then the list it has been cleared from the list. 28th is there. You can see 28th is still there. Yes, Ravi. Did we not create a Z node with E and another without? Yes, 28 Jan was created without minus E. So it is existing still. So you can see slash 14 Jan. Okay. So here it exists. All right. Sunesh's question is why ephemeral node is deleted? Is it for security purpose? So there are many use cases. It is by design. As I told you, like I can see who are the participants in the list, right? So one of the very good use cases of ephemeral node is to monitor how many sessions are connected right now. Okay. For example, as I was explaining you, name node could monitor the data node up, which the data nodes which are live using Zookeeper ephemeral nodes. Okay, under a certain folder, all of the data nodes could inform this central service by creating their ephemeral nodes. Okay, yes, everyone. All right, wonderful, wonderful, great, great. Any other question at this point? These are very good concepts, and I found it really enriching while designing any software or trying to think of an architecture. And that's why I'm making sure that we go through it, although it's not part of any particular certification, but I strongly feel that these will be required when people discuss design. People ask you the design questions in the interview or during the work, and then it'll be very useful. Okay. Now, so in general, when you think about Zookeeper, you think about coordination. And in coordination, there are many constructs required. One of the constructs that are required is to monitor who is up and who is down. Okay, that can be done with ephemeral nodes, or just a construct where there is some config settings which are to be loaded and to be shared by everybody. That's shared via persistency nodes. Okay. Now, the third one is a very interesting idea called sequential Z node. Okay. So any ticketing system, when you have a support call or any kind of system, they generate a sequential number, right? They generate a sequential number. Job ID, ticket ID, or you could say task ID, and so on. They generate a ticketing number. And this ticketing number could be very complex when you have many machines trying to generate a sequential number. When you have like 100 machines, all of them trying to generate sequential numbers such that no machine would create the number twice, and everything will remain non-overlapping. Okay, so that the numbers are unique and are in sequential and so on. In such case scenarios, designing such system could be decently complex. Okay, and that's where Zookeeper comes for the rescue by providing something called sequential Z node. Okay, something called sequential Z node. A sequential Z node, basically, when we try to create a sequential Z node, it creates a node with the sequential number appended to it. Okay, Say for example, to create a sequential node, we have to say create dash s space and then the name of the node followed by the data, right? It will not create slash zoo. Instead, it'll create slash zoo appended by a number. What is this number? This number is the running count of total nodes created in this particular parent. Okay? And it will keep on increasing monotonously. Okay? It will keep on increasing monotonically and will not decrease even if you delete the children node. Okay? Even if you delete the children nodes, it will not decrease, it will keep on increasing. This is a very useful way of generating IDs. A question from Sudhakar. Is there a limit for Z nodes, the sequence? Its limit is basically this number you see. This is the maximum possible digits in this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it can be 10-digit number. Okay, what happens when that limit is reached? I'm not sure. Honestly, I'm not sure. Most likely it'll give an error that too many name nodes or too many G nodes or something like that. Okay. But the interesting part is that you can avoid it by yourself. For example, if you are expecting that you will cover these many numbers in a year, prepend here the like the way we have put zoo. Similarly, you put the year number. Okay, 2017, 2016 or something like that. And that should be good enough. All right. Yeah, but again, I'm not sure what happens when the number is reached. And I don't think providing a prefix would matter because this number would keep on increasing monotonically, irrespective of what prefix we are providing. Okay. And or what the other interesting thing which can be done is we could create one Z node every year, and inside that we can create sequentially. So using this model, you can actually generate all kinds of sequential number. Okay. So Sahida's question is, who has the ownership of controlling creating the Z nodes data? Okay. As a general thumb rule, Zookeeper is editable by all. It provides the access control. We have not enabled too much of access controls right now. Otherwise, training will become difficult and you will not feel like creating ZG nodes. All right. So yes. So generally, all of the anybody who is trying to create the node can provide the security restrictions on the particular Z node, and that's how it is. Okay, so the owner of the Z node is the owner of creating the permissions of all the children Z nodes. Okay, a question from Manu. Right side 1/ in between zoo and sequence number. Yeah, this is an interesting part. So here on the right hand side, what you see is we have not provided any prefix. Here we have provided a prefix called zoo. Here we have not provided any prefix as such. Okay, any prefix as such. And therefore, there is no prefix in the generated Z node. Okay, let's try to test it out. Okay, we will create under 28 Jan. Okay, we'll create -s. Okay, and inside 28 gen, and let's say this is my prefix and this is my sum data. Okay, so minus a is the wrong one. Okay, now you can see that it created a z node. You see number two. Why? Because we created SG earlier in this, but under this particular G node. Okay. If we keep on just calling the same command again, we'll keep on creating more and more Z nodes. Okay. So you can see here, and yes. All right. 2, 3, 4, 5, 6, 7, 8. And if I say 9. All right. Okay, so why 2, not 1 or 0? Because the everything starts with the 0. Okay, so first number would be 0. 1 was SG and 2 was TRP. 0 was SG and 1 was TRP, and that's why the sequence number is this. Okay, so every node keeps a track of all the Z nodes created. Okay, every node keeps every Z node keeps a track of all the total number of children, and that total number is the one which decide what should be the sequence number. Okay, so DD is some data I have just put. Okay, DD is some data I have put. I could put Ravi as well. Okay, so irrespective of prefix and irrespective of whether we are deleting a Z node or not, this number will keep on increasing monotonically. Okay, whether I'm creating or you are creating under a particular Z node, this number will keep on increasing. Sunny's question is the sequence guaranteed? Okay, sequence is decided by number of children. So if you created a non-sequence number children, that will increase the sequence and might appear that there is a gap. Okay, for example, you have here 2, 3, 4, 5, 6, and 7 and 8. Okay, 9 and 10, but there is no 0 and 1. Okay, why X is created with 1, 0? X is started with 1. So just given any prefix, it doesn't matter what prefix we give. It's monotonically increasing, you see. 2, 3, 4, 5, 6, 7, 8, 9, 10. Whatever prefix we provide, it appends the running count to it and creates the Z node. Okay, it appends the running count to whatever prefix we provide. If you don't provide any prefix, then also it'll create a Z node without any prefix. Okay, sounds good? You can see I'm continuously creating the Z nodes. All right, Sudhakar and Ravi and everyone. Is everybody with me on this? All right, so now you know that if you have to build your own service, which will run on many machines and which would require coordination, who do you need to talk to? It'll be Zookeeper. Okay. Yes. Zookeeper is like a whiteboard with name node that is active at a given point. So what is the practical application of these variations of these node? Okay. So right, right. So there are many practical applications of these nodes. For example, I'll show you the really practical application. For example, okay, Hive server. Okay, Hive server has these many nodes created. You see, there'll be a comma separated one, and I could say, um, Okay, and I could say get. Okay. Now, what is interesting here when I said get Hive server 2 and this, right? There are many Hive servers right now which are connected. And you can see ephemeral owner is non-zero, which means these are non, these are going to be ephemeral. This is an ephemeral node. And under Hive server 2, there are these two machines, you see. One is this G node, other is this G node. Also, by now, you must have realized a G node could contain the special characters. Okay, it could contain special characters excluding space and excluding slash. And so what is going on here? Both of these Hive servers have informed Zookeeper that, hey, we are alive, we are up, and our IP address is this, and we are running this particular version number, and so on. Okay, and on top of it, the extra data like what is the transport layer and what is the host binding, are we using SSL or not, the other information about the server they have kept inside the data. Okay, so some data inside the name, some data inside the znodes data. Okay, so this way both of these servers are informing a central party that, hey, we are alive and our data is this. Okay, so you can see the practical application of ephemeral node, right? The second example of sequential node, it wasn't little clear to us that what is the practical use case of a sequential Z node. Sequential G node is a very interesting idea. It's a very interesting idea because if you think about any customer support system, right? Any customer support system, any, let's say, even every email ID is a unique ID. Every email ID is a unique ID, and no worries, Ravi. No worries. Don't. There's no limit on the number of sessions. It is up to me. I'll make sure that the learning will be complete, and we will. I think this way we all. I mean, if you feel like you also contribute as the answer by typing, and I feel that there is a need of explaining what I'm doing right now. Okay. So no worries. Don't worry about that. Okay. So let's try to come up with a better answer to the question that what's the practical use case of a sequential number. Sequential number is required by any ticketing system, any say customer feedback system. Probably every system requires a way of generating this unique ID. And why I'm able to connect to it, and you may not be able to connect right now, but when the need arises you will realize this part. So like in database, there is a the ID gets created when records are added into the system, right? It's a similar concept, just that it's a little bit more generic. Okay, Mohsin's question is it service registry for service discovery? Yes, it could be used as service registry for service discovery. A question from Sudhakar. Do you have similar Z nodes for sequential Z node? Yes, you can have children Z nodes to the sequential node. All right, no worries, Ravi. So I'll make sure that we will continue. Okay, so you can create the way we have been creating the G node. I'll show you this. Okay. All right, let's just take a look at the Okay, so let's try to create a Z node under this particular. Okay, let me show you. Create minus S and good. All right, so you can see that. Uh, Sorry, you see under this particular Z node, we have created another Z node. Okay, it's also a sequential number. Now you can see that if you're using this tactic, you can create huge number of sequential ID. Okay, no worries, no worries. Yes. All right. So George, please feel free to ask questions, and I'll make sure that I'll be able to answer those questions. These are since we are getting warm up with this coordination thing, because distributed computing is coordination and distribution. Okay, when you have many machines working together, you will need coordination and so on. So that's why these questions will be important. And trust me, when you build something which does two things parallelly, okay, like for example a thread or a distributed system, it gets difficult to solve the problem as well as debug the problem. Okay, all right. All right. Therefore, it's very important to get comfortable with the thought of doing many things together. Okay. A question from Alvin, a good question. No limit to the number of sequential Z node labels. I'm not sure. Okay. All I can tell you is since Zookeeper keeps entire data in the memory as well as in the disk, so the memory would pose a limitation. Okay. Other than that, I don't see that Zookeeper poses any kind of limitations. Okay. All right. So we have done this already. So these two parts you can try at your own by setting data to a particular Z node at later point of time and so on. Okay. All right. Now the second part. So first part we did create the Z node and did the hands-on as well. So you can also try to create your own Z node, which is ephemeral, and then exit and then come back again. So has anybody created other than under this particular 28th Zen? Okay, let me check. What's how many of you have created there? Okay. So other than TRP and all right. So I think I1 is yours, Rahila. I guess so. Okay, so try creating an ephemeral node which might disappear. Okay, just test it out. Create minus E, and under this, I will create this time something like SGIRI. Okay. Oh, sorry. Uh, Good. So this one is a sequential node, while this one is an ephemeral node. Yes. Thank you, Rahila, to answer Ravi's question. Okay. So feel free to create your ephemeral node, try exiting. Yes, I can see it, Srini, and I can see that you have created the Z node. Let me take a look. Okay. Yes. Okay. So this one has disappeared. That means was it ephemeral node? Okay. All right. Wonderful. Okay. So yes. So you can see that we can actually coordinate. I mean, between you know multiple systems this way. Okay. All right. So yes. Actually, it's not 18 Jan. I think it's 28 Jan. Okay. All right. So the next part, which I'm going to discuss, is further more interesting. And I'm very happy that my connectivity is going on well so far. Okay. Because I've changed the office and I was very much worried whole week. All right. So should we move on? Everybody tested it out? Good. Wonderful. Let's move on. All right. So the next part, which is interesting, is how does Zookeeper does what it does. Okay. So maintaining data, maintaining storing it is easier. What's more interesting is how does it handle the load. Okay. So the architecture that we are going to discuss is something unique which you have not studied so far. Okay, like the way we talked about two architectures so far. One was yarn, yet another resource manager, and another was HDFS. In both the cases, we always had something like a master slave model. In case of yarn, we had this master called uh, what do you say, we had the master called resource manager, right? RM. In case of yarn, that was the master, and the other ta node managers were basically kind of slave. Similarly, in case of HDFS, the model of name node versus data node is master slave kind of model. Okay, the problem with those both models is the master is singular, therefore not highly available. Okay, meaning what does it mean by highly available? Highly available means if one goes down, we should have uh, suddenly someone else taking its place. Second, second, okay, was there a lot of sound from a dog barking? Okay, okay. So I might have to do a little soundproofing. Okay, so coming to it, the architecture in case of those master slave kind of models, those are prone to non highly availability. Highly availability means two parts. One, there's always somebody to answer your queries. Second, when there are too many customers or too many clients, they should be able to act together. They should be able to read data simultaneously from the server. Okay, we should not have this bottleneck somewhere. And that is the problem Zookeeper tries to solve. Okay, so it runs in two modes, standalone. Okay, Rahila, could you, or somebody else, could you answer Ravi's question? Or should I, let me just paste the command. Create slash 14 Jan slash 28th Jan, and so minus S, and then we have some data. This is what I did. Okay. All right. Back to the architecture. So Zookeeper has two ways of operating. One is standalone, other is replicated. Standalone is basically running it on one machine, which is not really practical and nobody runs it that way. And it's not interesting at all because it does not provide highly availability, and that's the whole objective of Zookeeper. Okay. As we saw just now that even HDFS and all these systems, they all use Zookeeper. So Zookeeper has to be highly available. Therefore, it provides a very interesting architecture. We call it replicated. So how does it work on replicated? So please pay attention. If you are, is everybody done with creating the Z node, Ravi? I would love to, I can wait if you want to finish it. Good. If you are in the middle of something else, we can drop it and we can go back to that later. Okay, let's pay attention to the architecture. Okay, I'll try to answer Rahila's question. Can you specify a difference between Yarn and Zookeeper? Yarn's objective Yarn was to execute things on many machines. Objective of Zookeeper is to provide a coordination, just provide a whiteboard. Okay. So Yarn can be thought of as operating system to which you give the task and executes on many machines, while Zookeeper is more like a database or registry. So it's like data is being loaded by Zookeeper. So it's, yes. So data is basically kept in Zookeeper. The clients keep on creating data in Zookeeper. Okay. So Yarn is resource provided? No, actually. Yarn is for doing the execution of anything. When you, like the way on the console, when we execute a command and press enter, that command get executed on that machine, right? In the same way, if you want a command to be executed in the cluster on hundreds of machines parallelly, then you use Yarn, okay? HDFS is for providing humongous storage. Okay, Zookeeper is for providing small storage, but in a very highly available model. Okay, okay. So I hope that's clear. All right. So Zookeeper has been designed to be really, really highly available, and it runs on a cluster of machines. Zookeeper runs on a cluster of machines. We call it ensemble. The way we work is that we install Zookeeper server on, say, all the machines in our network, then inform all these servers about the whole list of servers, right? So every server knows about every other server, and then we turn it on, and then they start talking to each other. Okay, so Zookeeper, the Zookeeper client that we were using so far, under the hood, it was talking to
talking to these multiple machines. Okay, let's try to understand how does it happen. So we install Zookeeper, Zookeeper server as well as client on all the machines in the network. But lucky for us, the whole process was done by Ambari for us. Okay, but under the hood, what Ambari did was it installed Zookeeper on all the machines. All the Zookeeper servers running on each individual machines knew about each other. Okay, and this whole this is called ensemble. Ensemble is all these machines. Okay, now once you turn them on, they start communicating with each other. Under the hood, they're actually right now talking to each other, and they are basically uh, there's an election going on right now. There's election going on under the hood, and I'll discuss that part. The election mechanism is derived by an algorithm called Paxos. We will discuss it briefly today. And as long as more than half of this list of machines, more than half of these machines are available, Zookeeper will work. Otherwise, it will become read-only. Okay? Otherwise, it'll become read-only. Let's try to understand what happens when you turn on the the machines. Okay, since all machines know all machines, these machines have to select one leader. Okay, they will do the election under the hood, and all of these machines will give the votes for all other machines, and then the machine which gets the maximum vote will become the leader. Rest will become the follower. Okay, and on what basis? What is it that's counted as a vote? Vote means I will vote. I mean, a machine gets higher vote if machine is having the highest version of the data, the most recent version of the data, because all the Z nodes would be having copy of the same data. Okay, whatever G nodes we were creating in the memory, sequential node, all of this whole structure is on all the machines. So whichever machine has the latest data, generally that is selected as the leader. Okay, so machines elect one of the machines as the leader, and others automatically become the followers. This phase is finished when majority has synced their data from the leader. Okay, meaning the leader has delivered the content, the latest version of the data to all the majority. And at any point of time, if leader fails, the election will again happen. Okay, or in case majority of the machines are not available, the leader will step down. Okay, now what's the role of this leader? They elected a leader for what? The leader is the one who provides the modification to the data. Okay, while the request to read the data can go to any machine. So there are three machines you can see: server 1, server 2, server 3. And these are the users like me and you. They are trying to talk to this is an ensemble. Okay, and this leader contains so these three machines gave the votes to each other and elected this machine as a leader. And this leader essentially provides the response to the modification request. So when the client says, I want to write the data, let's say this client is asking to write the data. What does it mean by writing? Creating a Z node, updating a Z node, or deleting a Z node. Okay, deleting some data. So if a client requests for modification of the data, the client's request gets redirected to the leader. Whosoever is the leader, he will receive, whosoever is the leader, that leader would respond to the modification request. Okay, so you can see that the write request has been redirected by the follower to the leader. Now leader and client will talk and will modify data. And as soon as this modification happens, leader will further send out the new copy of the data to all the machines. Okay, and all the clients also get the list of all the machines in the network, right? Client is client library under the hood. So Zookeeper Desk Client was maintaining the list of all the servers, and one of the servers, out of that would be marked as leader. That also will be updated quickly by the client. It'll be client will basically keep itself updated with the list of znodes, a list of Zookeeper servers, and who amongst those Zookeeper servers is a current leader. So client library does all the magic of session creation and tracking who is the leader and so on. Okay. So Nitesh's question is, what the client write generally to Zookeeper? So far, when we created our own Znode, we were the clients. And we were informing Zookeeper about that we want to create a sequential Znode, or we want to mark our presence, or we want to update the list of data, list of Hive server clients, and so on. Hive server, Hive servers, basically. Okay, that's what we write. All right. A question from Alvin: does leader gets replaced with another leader if that machine gets more recent data? No, no, actually, because if there is a leader and it's going on well, then all the requests are anyway going to the leader. So leader will be having the most recent data. Okay. Yes. And the polling, this election happens automatically. Yes, there are two scenarios. One is, all right. So these all machines, what happens is, okay, let me reiterate whatever I said because it's important, very much important. And Paxos algorithm is a very important discussion topic for anybody who loves to understand the distributed systems. Okay. So let me try to explain what does it mean by, what does it mean by Okay, let me try to explain what does it mean by election. So all the machines we have installed Zookeeper on all the machines, then we turned them on, then they started communicating with each other, and then they started election process, and then they elected one of the machines as the leader. And once election has been done for the leader will be the one who will respond to the modification of data requests. For example, creating Znode, creating updating one, or deleting data, and so on. So those kind of requests will be redirected by all the followers to the leader, right? And at any point of time, if leader goes down, the election will rehappen and somebody will be made leader. Second, in case there is a majority is not available, meaning say half of the nodes are down, okay? Half of the nodes are down, therefore there is no longer a majority. Okay, more than 50% is not available, and there will be no election. Okay, the whole system will become read only, and after a point of time, Zookeeper will expire, and they'll say that it's better to shut down than run with old data. Okay. A question from Sahida: can the same Znode data is shared across the clients? Can the same Znode's data is shared? Yes, yes. So Gnode is like file, and as you created your Gnode, I was able to see that Gnode. Okay, but you can put the restriction, security restriction on your data, such that nobody else can read it. All right. So a question from Rahila is that means you are leader and we are followers or we are clients. So actually this model in which we are operating right now is more like HDFS model. Okay. Why? Because I am designated as the instructor and the singular entity. Unlike Zookeeper, in case of Zookeeper, from time to time the election happens and somebody else becomes the leader. Okay. So had it been like a typical Zookeeper model, so maybe Rahila could have been the instructor right now, and so okay. In case I have a cough and somebody else takes the lead and says, "Okay, I'm the instructor for today." Okay, and so that it could have been that way. All right, and a question from Manu: before electing leader, also these create kind of operation will happen, right? No, if there is no leader at any point of time, the modification or create kind of operation will not happen. All right, good question. Because it will be read-only until that point. So client will go to the follower and say, hey, I want to write the data. And follower will say that, no, we don't have a leader right now and the system is read-only. Okay, that's what would happen. If two or more servers have the same version of data, who would be the leader? Good question, Mahmood. So if two or more servers have the same version of the data, whosoever is responding with better ping will be elected. Okay. If again there is a tie, okay, if again there is a tie, one of them will be chosen at random. Okay. So the ping along with the version of data are the two things. How fast is a computer responding? All right. A question from Motion is there any config which I can read and understand? How many nodes are there in there and who is the leader? Very good question. So there is an interface that is provided by Zookeeper itself. Okay. It's called, I have removed that slide. Yeah. So it runs on 2181 port. Okay. 2181 port. And you can always, you know, on the console, you can say this and talk to this service directly. Say, you could say conf, okay? It is showing you the entire detail, all right? And you could see more things, okay? You see? All right, now you can see that. It is entire detail about, all right. I've moved it to the end. NC, okay, very good question, Ravi. Yes, I'd like to explain what is NC, and because we are going to use it again and again, all right? And it would come very handy for you, you know, to learn what does it mean by NC. Okay, so question is, what is NC? I'll answer your question, Manu, in a minute. Okay. Okay, so NC stands for Netcat in very simple words. So it has Is the voice okay? All right. Okay, so let me try to explain. So there is a very nice tool called NC, right? We had talked about services and people listening on a pod and so on. But NC would be your realization of thing that you can actually create a server quickly. Okay, you can create a server quickly, and I'll show you. Let's say, let me try to SSH. Okay, so if you want to say create your own server, NC is a good thing. Okay, and similarly, we have the NC does two roles. One is connecting to any service at a port. Okay, as we have discussed that most of the services in Unix listen to a port like 80 port, 8080 port, and so on, right? So if you want to connect to a service in a raw manner, okay, go and check and open the door and see if it is there. That kind of thing you can do using NC, right? Like for example, if let's say I'm told that NC, the zookeeper is running on 2181 port. So I'm right now connected to the local zookeeper server that's running on 2181 port. And I'm talking to that by typing in here, okay? I'm talking to this service by typing the command on the standard input, okay? So it's basically to provide you the network communication. NC is network communication, and we are talking to a service which is running at localhost at this port, right? That's first thing. So NC can act like a client. If you want to listen to a server, you can say NC and localhost, and you could also specify port. Okay, okay. So it's already in use. Already in use. Why? I think sorry. I'll just listen. I think this is better. Okay. So if somebody is connecting to local host, what was the port number again? Port number was 115. Okay. So they'll get whatever data I'm typing here. You see, this is some data I'm producing. Okay. So whosoever is connecting is getting this data. All right. I am the server. Okay. So the other one who is listening to the server, this is the client and this is the server. Okay. So I think these two modes are good enough. One is to listen listen on some port, and other is to connect to some port. Okay. All right. Did I rush through it, or did I make sense to you? So the first tab is the server where I'm saying NC listen to this particular port, and whatever I'm typing is like I'm server, I'm producing data. On the other hand, this client is connected to the server, and whatever the server is saying, it's just printing there. Yes? No? Okay, not clear, Rahila. So this NC is a very clear, a very easy tool. So we had been talking from the day zero, right? We talked about the data node, name node. All of these are services. They're listening on a particular port. Okay, they're listening to on a particular port. Similarly, the case of all of these services like resource manager, node manager, all of these are services. What are services or daemons? They run in the background, and the only way to communicate to them is via network communication, because they listen on a particular port. Like for example, HDFS listens on 50070. Okay, so here I'm trying to show you, if you have to quickly create a server, you can create your own server this way. Okay, nc minus l, this is the port on which this program is going to listen on. Listen on as in, this is a server I've just created on which people can connect to and read from. Okay, and this one, the second one, is a way of connecting to server. All right. So this is how we generally talk to various services or create a service quickly. Okay. Yes, data gets transferred both the ways. All right. Feel free to ask if it's not clear, because we are going to do stream processing or using NC at later point of time. Similarly, we will do Flume experiments using NC. So feel free to ask. Okay. Good. Good. Oh, we are already 9:40. Let's take a break for 10 minutes. We talked about quite interesting things today. We talked about JSON, we talked about NC, and few more ideas. All right. Okay. Before taking a break, let me answer one quick question. How many people can listen on a port? Only one service can listen on a port, but any machines can read from that port. Okay. Only one service can listen on a port. Only one machine. Okay. All right. We will be back by 9:51 p.m. IST. Okay. Let's take a break for 10 minutes.
All right. So can we start now? All right. Okay. So thank you, Ravi and Kar. I'm really happy that, okay, you like my sessions, and I'm sure that I'll keep up the expectations. I'll try my best to be on the expectations. Okay. All right. So should we start now? Everybody back? Wonderful. Wonderful. Let's start. All right. So, okay. So I think everybody's back. Yes, Manu. If only if only people could. So Manu's point is there should be some data for election, right? Right. So okay, let me try to understand the question. There should be some data for election. Based on the data, it is selecting the leader. Yes. So the data that we were trying to create earlier by creating Z nodes, and we talked about the sequence number, and they were actually every Z node maintains a sequence running number. Okay, that running number is kind of mark that whichever G node is having the most highest running number is having the best or the most recent data. Okay, so this stamp or this data is what is used to consider somebody a leader. One, how recent some machine is holding the data. Second, how fast a machine is responding to to a ping, to a ping, or to the network call. So that is the basis of election. Okay, good, good. Moving ahead. Yes. All right. So we talked about that we installed many servers in the network. Then they all came up. Then they elected a leader. Leader responds to the modification data queries, while all the other nodes, the followers, we call them, all the other nodes, we call them followers, they respond to read-only queries. Say, for example, ls, get, those kind of queries. Okay? And this election takes around 200 milliseconds. And if at any point of time, again, if the majority is not available, the leader steps down by itself. Okay. A question from Manu. Was I able to answer your question? Yes. And okay. Ravi's question is, what difference does it make if it is a leader or follower if all machines are serving the request? Okay, so not so the followers are serving the request which are only read only, while the write request, the modifications request, is being served by the leader. As you can see that this client wanted to modify some data. It went to the follower. Follower said that let me redirect your request to leader, and leader is the one who is doing the modification of data. So, so if you draw the diagram, if you draw the diagram here, like this. Okay, so okay, like this. Then there'll be these followers, followers, and followers, and the data is getting distributed. It's only one directional data. Okay, so changes are coming to the leader from the client, and yes. So Manu's question is, if data is in follow machine, so generally the leader that is elected out of all the machines is the one which has latest data. Okay, and since it has the latest data, therefore there is no point in transferring data back from any of the followers, right? And the client, when they are modifying data to the leader, they can read data from the followers, but for modifying, it will be the leader. Therefore, leader will be the source of truth at any point of time. Okay? Did I make sense, Manu? If followers get the request for a read, wouldn't the follower get the data from the leader and respond? No. Very good point. Very good point. Yes. So question here, what Mahmood is saying is a very valid point, and we all need to keep this in mind. Question is, if the follower gets a request to read the data and the follower responds by itself without talking to the leader, follower might be giving out stale data or outdated data or old data because follower has not received it might take some time for the leader to update all the followers. Okay, all right. So the followers basically talk, give out the stale data. That's true. Okay, keep that in mind. Yes, followers might give the stale data. Okay, we call this eventual consistency, not immediate consistency. In the long run, we know that leader is going to give out the data to follower, and then the life is going to be great again. Also, whenever modification requests are done, unless this leader informs majority, unless this leader informs majority, it does not respond successful. So a write is successful, a modification of data is successful only if this leader informs more than 50% followers. That means the chance of follower having the stale data is very low. Okay, so as soon as leader gets a modification request, it immediately broadcasts to the followers. I think that's a second phase. Okay, all the write requests are forwarded to the leader. The leader broadcasts the update to all the followers. When the majority of the followers have responded that we have successfully saved, then the leader commits the update, says, yes, it's finally done. And then it informs the client that, hey, here's the successful response. Okay. The protocol for achieving consensus is atomic, like two-phase commit. Okay. Machines write data to the disk before in memory. Okay. Again, machines save the data into the disk before in memory so that in case while we saving is something putting into the memory, it is not stale. Okay, therefore therefore keeping things into disk is a better idea because that's permanent. Memory is transient. All right, in case machine goes down, memory goes haywire. Question from Narendra: can we correlate this diagram to email example slide, please? Yes, we can. Okay, let me just take a break, take a further question, and then come back to your question. Question from George: if the leader goes down, who becomes the leader? Somebody else will become the leader. Again, the election will happen, and whosoever is having the latest updated data might become the leader. Okay. A question from Ravi: is that acceptable that client gets stale data sometime? Yes. That is the trade-off of distributed computing. Here, there's a trade-off of distributed computing, and we will discuss it further. It's a very important question which Mahmood asked, and Ravi has also followed up, saying, is it okay that the client receives the old data? So my quick answer is, there cannot be a system which is highly available. There cannot be a system which is highly available and still consistent. Okay? Strongly consistent. Let's talk about our traditional databases. Our traditional databases, whatever we studied, those databases were the databases that we studied. They were strongly consistent. Why? Because there was only one machine, right? And the problem with one machine was that it was not possible to provide high availability. Okay. So that is a trade-off, and it is okay to do that. And Zookeeper tries to minimize that. Zookeeper tries to minimize the inconsistency by writing to the majority. Okay. Yes. Great. Now another one, two more questions, and then I'll take Naren's question. Okay. A question from Rahela: what if more followers are added? Are there any chance for leader to change? Okay. So the way it happens is you have to inform all the machines that we are adding more machines in the ensemble. Okay. In the ensemble, if we are adding more machines, we will have to restart Zookeepers or reload their configurations. And so that there will be, so if we are adding more machines, the election will happen in the beginning again. Okay. And that's how it is done. Yes. So generally, if you're adding more machines in the network, more likely the leader will remain same because new machines don't have much new data. Okay. A question from Mahmood: once the followers have saved the changes, do they inform the leader? How? So when the leader receives a request to modify some data, it informs all the followers, and all the followers inform back saying we are done. And as soon as majority have finished, the the leader informs the client that, hey, we have saved your changes, and your changes are with majority of the machines. Therefore it is in safe hands. Okay. Is that what you're looking for, Mahmood? All right, good, good. A question from Narendra: can we correlate this diagram to the email example slide? Okay, email example slide was the use case of Zookeeper's data model. The email example slide was the use case of the data model of Zookeeper. And what we are discussing right now is an architecture of how Zookeeper is able to provide huge coordination amongst many machines. Okay, so if we have to build the problem which we started with, what would we do? Okay, what would we do? If I have to do it, I'll basically create a Z node called email indexers. Okay, email indexers. All right. Okay. And then under this, we will have the name value pairs, right? Name, I'll create every indexer, whosoever is picking up the email is going to, as soon as it starts processing, it'll create ID1 as the key of the email ID. Okay. And data will be the server IP address. Okay. The indexer's IP address. Okay. So again, I'll try to demonstrate again. Let's say there is this machine. There is this machine. I'm pretty bad at it, so sorry. Okay, let me try. So there is one machine, another machine, another machine. So these are three machines. Okay, and there is this central mail server. This is our email server. It's good that you asked this question because that will put everything into perspective. Okay, indexer 1. Okay, and indexer 2. Indexer 3. Okay, so this is what we have. So I'll try to explain what happens is indexer 1 went to the email server, picked up an email. This is the step 1. This is the step 1. And then it went to this zookeeper. This is our zookeeper. Okay, this is our zookeeper. And it has Z nodes under this. Okay, so indexer went to the email server, picked up few emails, okay, and checked if those email IDs are already created here. If not, if not, okay, so I'll say check. I'm pretty bad at it. Let me just type it instead. Okay, so check. If not found that email IDs, then it'll basically create. Okay, it'll basically create the email ID. Okay, this is how I would design if I have to design. So I'll create the design such that the name of the ID is email ID, the name of the node is an email ID, and the value, let me call it email ID 1, and the value will be indexer 1 IP address. That's my value of the node. This is the name of the Z node and this. Okay. So we are talking in terms of the data model. So indexer is a client to our zookeeper who's creating this data as and when it needs to. Okay. Now indexer 2 will come and pick up some of the emails. Okay. And we'll check. So indexer 1 has created this. So indexer 1 has created email ID 1 and then goes back to process the, so I'll just say, this is called, say, indexing process. Okay. And then next step could be mark email as read. Okay. Here, read. Okay. List, pick unread emails. Okay. The first step is to pick the unread emails. Then for each of them, check which email ID is not existing here. If not those email IDs existing, then we create a Z node with the email ID, and this same process is being done under everywhere. They are all client. Okay, so this this whole process is being handled. This whole process is being handled by Zookeeper. These are the clients. Okay, these are the clients. Okay, so I hope I answered your question. And yeah, so this way people use this Zookeeper as a mini data store. Okay, so Zookeeper, you can always think of it as like a mini data store for which is highly available and can provide you great constructs for coordination. All right. Okay, so here's a question for all of you. If you have three nodes, A, B, and C. No, the email discussion was basically Zookeeper discussion only. Okay, it was Zookeeper only. All right. So if you have three nodes, A, B, and C, with A as the leader, so we are talking under the hood right now. The example which I've given is basically the use case of Zookeeper. Okay. The elections, the Paxos algorithm, the ensemble, and other things are part of the architecture. Okay. So if you had three nodes, if we have three nodes, A, B, and C, A was the leader, and A suddenly dies as in shuts down. Will someone become the leader quickly? Yes or no? Yes. So either B or C would become the leader. Okay. Either B or C will become the leader. All right. If you have three nodes, A, B, and C, and both A and B die, okay, let's take this scenario where you have A, B, and C. C being the leader, and both A and B die. Will C remain the leader, or will C step down? Anybody? C will step down. Correct. C will step down because there is no majority. 2 out of 3 is a majority. Two out of three machines is a majority. Therefore, elections will not happen. And even if somebody was the leader, they will step down. Okay, these are really honest people where where they have some dignity that they step down. Yes, so it's a crisis scenario. Yes, so C will remain read only. The cluster will become the read only. C will step down and nobody will be the leader as majority is not available. Okay, C will remain, nobody will be the leader, but it'll be become the read only. Now, question that we are trying to haggle with that I mean, we are trying to understand a scenario. Imagine we had 10 nodes. Out of 10 nodes, 10 machines out of 10 Zookeeper servers, let's say 5 of the server are dead. Okay, remaining 5 are active and working fine. There is no problem with 5 of the machines. Half of the machines is still active, which is 5. Now question is, with 5 machines, still there will be no majority, and therefore there will be no leader, and the entire Zookeeper cluster will be read-only. So don't you think that it is waste of resources? we still have 5 machines and our cluster is read-only. All right. If we have 10 machines, 5 of them are dead. Okay. 5 are active. So will somebody be the leader? Anybody? Same question, but with 10 nodes, we have 10 machines, out of which 5 have died. Will somebody become the leader? Okay. Right. So out of 10 machines, if 5 are dead, there will be no leader. There will be no leader. Okay. And no elections. Even if there was a leader, it will step down and there will be no longer a leader. The cluster will be read-only. And after a point of time, if the cluster remains read-only for quite some time, it will automatically shut down. It will choose to shut down, then keep on catering older data. In these cases, what you have to do is you have to shut down the entire Zookeeper cluster, change the list of nodes to 5, and then turn it on again. In that case, 5 out of 5 will be available, and again, it'll start going good. Okay, but question here is that even though we have 5 machines working and the entire Zookeeper cluster is useless, do you think there is a reasoning behind it? Do you think it's logical or efficient? Anybody? Any reasoning? Any reasoning behind majority, behind need of majority? Yes? Yes. So HA is not acceptable. Let's try to concretely answer this. Let's try to take a case of 6 nodes. Out of 6 nodes, how many nodes need to be available? Quickly. Minimum how many nodes you need for election to happen? Out of 6? 4. Correct. Correct. All right, let's take this case. This is a very interesting case, and I'll try to answer your question, question regarding why do we need the majority? Imagine we had 2 data center 1 and 2. Okay, data center 1 has 3 nodes A, B, C, and 2 had D, E, F. A being the leader in the data center 1. And after some time, something bad happened. The connectivity between the 2 data centers went down. Now imagine if there was no restriction on election, meaning the majority was not required. If the majority was not required, what would happen is what would happen is both data center 1 and data center 2, both, since both of the all of the nodes are running fine, they could hold an election, and there will be two leaders. Correct, Manu. There will be two leaders, and these two leaders will start accepting the changes on both the server, both the data centers. Data center 1 being in India and data center 2 being in New York. They start communicating with each other, and then since the client has the list of all the machines, right? And they might start updating the two leaders in totally disconnected way. And both A and D will basically have their own versions of data, which will be unreconcilable, right? If we have two notebooks, me and you both are writing and we are both are changing things. Now, at the end of the day, it'll be unreconcilable, okay? Then therefore, they put down the majority, the rule of majority. Why? Because only one, only one segment of the whole cluster can get the majority at a time. There can be only one majority of the entire network. It's like, um, all right, it's a bad example, but I would like to give. What's the biggest? If if you were to say that uh, you are a really angry kid, and you say that since it's my birthday, I want the biggest piece. What would be the easiest thing for you to do? If you say that you want the biggest piece of the cake, what would that be? No matter what. If you get slightly bigger than 50%, it's guaranteed that you got the biggest piece. Yes, the whole cake is yes, but that means that you are not sharing with anybody. Okay. So you are sharing, but you're saying that I want the biggest piece because it's my birthday. The biggest piece of the cake could be slightly bigger than half of it. Yes? Similarly, here we are saying there would be only one majority no matter how our network is architected. There will be only one majority. Only one section of the network, the way you cut it. Okay? Howsoever you cut it, there will be only one section always that's a majority. Therefore, therefore, the election needs majority to vote. Otherwise, there are chances of multiple leaders. A question from George: if you restart both data centers and reconnect, will this sync and begin the election process and both will have the same files? Yes. So imagine that actually, if this happens, right? If this happens in true cases, here we have taken a hypothetical case. If there was no majority, therefore there were two leaders, and hence, if you connect it, it will not be possible to reconcile these data of A and D because both the leaders have changes, and therefore it's impossible to reconcile these changes, even if this network gets connected again. All right. Now, therefore, in this case where the connectivity between two data center 1 and data center 2, when this connectivity goes down, what would happen is here all three DEF will observe that there are only 3 out of 6 available, and therefore they will not hold an election. Similarly, this side also, they will observe that ABC, only 3 nodes are available, therefore there will be no election. So in case the connect in reality in Zookeeper, if the connectivity between these two data centers goes down, what would happen is there'll be no leader. Okay, so Ravi's point, did it make sense, George? So if we don't have majority kind of need, there could be two leaders and it'll be data will be beyond reconciliation. Okay. Question from Ravi. Are you saying only when the available nodes are in minority, you conclude that it could hurt the data integrity? Yes. Okay, otherwise it is assumed that we do not have any such broken network between two data centers. No, we always assume in case of Zookeeper's design, it is called something called Paxos algorithm. Paxos algorithm has been designed to keep in mind that the network partitioning would happen. Arbitrary shutdown of the network would happen, and your database or your system, whatever we design, whatever database or system we design, it should it should be able to tolerate it. A question from Vikas: what happens if data center 1 has 4 nodes? Great. Let's say data center 1 has 4 nodes and data center 2 has 3 nodes. All right. So let's say that we have this kind of a scenario. Okay. Let me try to. All right. Say we have 3. Let's say here there is one more node called A1. Okay. There are 4 nodes this side and 3 nodes this side. Okay. So in case the network get disconnected, here there will be a majority. What is the majority out of 7? 4 is a majority, which is half of 7 is 3.5 and 4 is more than 3.5. Therefore, there'll be a majority this side and hence A would remain the leader. Okay? Correct. Correct, Rahila. That's the right answer. Vikas? Wonderful. Wonderful. Let's move ahead. Okay, again, same question. An ensemble of 10 nodes can tolerate a shutdown of how many nodes? Yes? Correct. Good. All right. Wonderful. Wonderful. Okay. It's a little too much theory right now, but don't worry. It's not too hard. We all know the psychology of, I mean, we do far more complex thing in our normal life. Okay. So let's try to understand. We talked about ephemeral nodes, right? We talked about ephemeral nodes. Ephemeral nodes disappear when session ends. So Tegu's point is where the HDFS take part in email server and Zookeeper, we don't use we did not use HDFS in that. Okay. Okay. Because it's totally independent of HDFS. Yes, Zookeeper is a small storage. All right. HDFS is just opposite of Zookeeper. It's a humongous storage, while Zookeeper is a small storage. All right. So the client has a list of servers in Ensemble. The client, when we say client, we are talking about the client library, the client, the software that we are using, the command that we used called zookeeper desk client is a client. Okay. This zookeeper desk client, the command that we used, it under the hood is maintaining the list of servers in Ensemble. All right. So that's right, Ravi. Zookeeper has a cluster of its own, and storage is local to that cluster. On every machine, it stores data on those machines. Okay. All right. A client has the list of servers in Ensemble. It tries each until successful. A client has a list of servers in Ensemble. It keeps trying each until successful. Server creates new session for the client. Okay. And the timeout is provided by the client. If the server if the server has not received a request within the timeout period, it may expire the session. In very simple words, the client keeps on sending heartbeat to the server continuously. Okay. If the heartbeat is not received by the server for some time, it would expire the session. Okay. All right. A question from Kar. Why we need Zookeeper? We can store the same data in HDFS as well. Sorry, I'm confused with the need for Zookeeper. So in case of HDFS, the problem was that it is not great for many things. One, HDFS is great when we want to append data. And HDFS itself does not provide a high availability system. As we talked about, there is a name node, and this name node is always a single machine. So if we have to have multiple name nodes and switch between them, those kind of mechanics are not provided by HDFS. Okay, so coordination cannot be greatly done with HDFS because data is append only, and it'll become very slow and uh, buggy. Okay. All right. So to store humongous data, you use HDFS. For coordination and other constructs where we need, say, maintaining a central registry or providing high availability, that can be done using Zookeeper. Okay, did I make sense, Kar? Manu's question is, client itself can be the followers. So client can be installed on any machines. Okay, it can be on any of the followers. It can be outside Zookeeper cluster, or it could be a software that you have designed. Okay, so client could be anywhere. Great questions. Moving ahead. So for example, take a look at this kind of use case. Imagine you have built a very highly available service that's being used by many machines. Okay, and this service is running on many servers. Okay, and these clients cannot keep on tracking which servers are up and which servers are down. Therefore, you need Zookeeper in between those. Okay, you need a Zookeeper in between those. Let's take a case, very simplified case. We have two servers, cow and the duck. Both of these servers on the left hand side here, what you see is you have these two servers, cow and the duck. Cow informed zookeeper that, hey, create my ephemeral node called duck under slash servers. Similarly, this second server informs the zookeeper. Second server informs the zookeeper that creates my ephemeral node called cow. And then afterwards, if a client comes into play and says, give me the available servers, you will get duck and cow. After some time, the duck is killed. This particular machine is dead. And duck server is killed. And at that point of time, after 5 seconds, this this since this was a ephemeral node, it will disappear, and you will only get cow. At this point, if a customer comes and says, give me all the servers, it'll be only cow. So client did not have to worry about tracking which machines are up and which are down. It only had to check at this place. Okay, it only had to check at this place. Okay, a question from Rahela. If the server stops, then the cow will not be shown. Yeah, in case, let's say there could be one more scenario that zookeeper might shut down, some of the nodes might shut down, but still it'll be read only and it'll answer to this question. Okay, all right. And in case this machine shuts down, let's say car one, afterwards this will be an empty and there'll be no servers to cater to. All right, great questions. There are quite a few guarantees that Zookeeper gives. It provides a sequential consistency, meaning the changes will be sequential. Okay, as I said, that it does not provide a strong consistency, as question raised by Mahmood, that what happens when a particular follower has not received a recent update from the server or has not applied that recent update and the client request comes to it. In those cases, it will definitely provide old data, but there'll be a sequential consistency that if newer changes come in, those will be applied in the same manner. Atomicity. The changes update will either succeed or fail. There will be no intermediate state. Single system image. A client will see the same view of the system. Durability. Once an update has successful, it will persist. It will not be undone or dropped. Timeliness. Rather than allow a client to see very stale data, a server will shut down. If Zookeeper remains read-only for some time, it will automatically shut down. Okay, we have seen this happening in our CloudX Lab case. Okay, all right. So basically, these are the operations which Zookeeper provides you. Create, delete, exist, meaning ls, and get access control list, set access control list. Access control list means to provide the control over who can access, who cannot. Okay. Get children, get data, synchronize data, and so on. Okay. It also provides, Zookeeper also provides multi-update facility so that multiple changes could be batched together and either all will succeed or neither will succeed. Okay, it's a very important idea. The way we stitch things together in transactions in our traditional databases, we chain the various changes in a single transaction and make those all the changes together. Similarly, Zookeeper also provides you the ability to create multi-updates together. There are two core APIs, Java and C, okay? And other than using from the command line, you can use the Java or C API. There are many contributed API in Perl and Python. Okay. Most important part about APIs is to understand that there are two kinds of APIs. One, asynchronous API and synchronous API. What does it mean? Synchronous API is application programming interface. When one component talks to another, they generally use API rather than raw communication. Okay, API is like function calls or creating objects using the programming language. Okay, so the APIs are, in case of Zookeeper, have two forms, synchronous and asynchronous. What does it mean by synchronous? Let's try to understand what does it mean by synchronous. Okay, before that, I'd like to take Mohsin's question. Like Yarn has alternative to itself called Apache Mesos, then similar line is there alternative for Zookeeper, which provides similar functionality? So Zookeeper is kind of, you know, mm, kind of one of its kind, because most of the other systems have tried to provide embedded models. Like, for example, let's take a case of MongoDB. MongoDB provides its own election mechanism exactly on the lines of Zookeeper. So the MongoDB does not use Zookeeper, it provides its own. But Zookeeper, I'm not aware about any other system similar to Zookeeper which just does the coordination. Okay. A question from Ravi. Am I correct in assuming big data is not dependable for critical transaction-based systems such as banks, etc., due to potential failures, due to high availability of distributedness, and dependence on the network, etc.? And big data is generally used anywhere other than transaction failures won't cause catastrophic consequences. Kind of, yes, you are right in that way. So when you have transactions that can be handled by existing mechanisms, you would be happy to continue that way. Otherwise, the way we did at Amazon, right? At Amazon, we had this humongous storage and humongous requests. We cannot go in either way. Neither we can continue. We were using Oracle databases, okay? And that was not really scalable. Okay, so we will talk about it again. So we suffered a decent amount of pain while using Oracle in case of Amazon on a high scale. So what we did was, in the entire system we broke it down into parts. Only in the cases where the money transactions was more important, that part we did not touch. Rest of the things like maintaining the inventory, keeping the details of the website and all of this, we moved away from Oracle. Okay, so, and the big data systems are not really too much unreliable. We are talking about a stale data for millisecond maybe. Okay, so when you design a system, you have to keep that in mind. So in a way, yes, when there is a strong transactional kind of dependencies, we need to break those systems down and extract out whatever can be delegated to distributed systems. All right, wonderful point. Great. Let's talk about synchronous and asynchronous function call. Okay, synchronous call is the usual function call that we have been doing so far. In this synchronous call, what happens is we make a call to a function and then wait till that function call finishes. The logic does not move ahead. A processor does not move ahead. It will wait for the function to finish. This is asynchronous call. While, sorry, that is synchronous call. I'm extremely sorry. Synchronous call means you have to wait till the function finishes the work. In case of asynchronous call, we move ahead. We move ahead even if the work is not finished. Instead, we say that, please let us know once you are done, we are going to do our work. That's called asynchronous call. Here, we are making a call and moving ahead to do something else and telling that once you are done, just call this particular call back. We hand over, we hand over a piece of logic called callback, which is itself a function. Yes. So these are the differences. Thank you, RS. ATM transaction is synchronous and email transaction is asynchronous. Yes, while because when you click on send in case of email, it submits. Okay, it submits. And when it sends in the background, once it is done, it gives you an alert saying the mail is sent. Okay. So these are the two forms of API calls which Zookeeper provides. And it provides something called watches. Watches are the trigger that get executed by the system. So you can schedule your watches on Zookeeper saying once something interesting happen, please execute this logic. And these watches finish as soon as they are triggered only once. So in case you want something repeatedly to be done, you might want to re-register in the notification itself. And you can create your trigger or watches by the way of calling functions like exist, get data, and get children. So the watches of exist get executed when znode gets created, deleted, or data gets updated. Okay. Similarly, for get data, the triggers of get data gets executed when a particular znode on which we did get data, that znode gets deleted or its data is changed. Okay. Similarly, the triggers of or watches of get children gets executed when the node gets deleted or it's any of the children are created or deleted. Okay. So the other part of Zookeeper, which is important, is access control list. So it's important to know that we can determine, we can restrict who can perform which operation on Zookeeper by the way of defining access control list. Why this is important? Why is access control list important? Because Zookeeper as an application is going to be used by entire organization, entire organization, applications of entire organization. So there will be, there are three parts of authentication. Digest, meaning there are two parts of ACL. One, authentication, meaning who is the user, and authorization. Okay, authorization, who can do what. Okay, so it depends upon authentication, identity, and set of permissions. Authentication can be three kinds based on IP address, based on digest as in login password, and based on Kerberos. Okay, so this is access control list. Zookeeper provides ways of defining this. In the Zookeeper client itself, you can define these things in the argument itself while creating a node. While creating a node, you can specify that as one of the arguments. Okay. Now, these are the few use cases which we have already discussed. You can also build a reliable configuration service. Also, somebody was asking, I forgot to mention that. So Mohsin's question regarding alternative to Zookeeper. At Amazon, we had our own similar system like Zookeeper internally built in order to provide a similar configuration service. Okay, we used that central system of Amazon for configuration service. A distributed lock service. Okay, you can, if you want to build a method such as only single process may hold the lock, you can build that. This is what we demonstrated by creating indexers for the email. All right, now, so far we have been very gaga about Zookeeper. Let's understand when not to use Zookeeper. We should not use Zookeeper if we are trying to store big data. Do not use Zookeeper for big data. Why? One, entire data gets loaded in the memory. And also keep in mind that entire data is replicated. So if you have n servers, there will be n times data storage. Okay, if you have 100 machines and you're trying to store metadata of 1 GB, it will actually take 100 GB of RAM and 100 GB of disk if you count in the entire cluster. So entire 1 GB will be in the memory of all the nodes, similarly in the disk. Therefore, there'll be a network load. So if you have bigger data, keep in mind not to keep it in Zookeeper. Okay. Second, if you need to have strong consistency, as we had pointed out earlier, that there might be slight delay in the uh, there might be slight delay in getting data to the follower, and therefore follower might keep on providing little stale data. Therefore, it is not strong consistency. Therefore, Zookeeper does not provide strong consistency. So in case you want to store bigger data, use HDFS instead. And in case you need strong consistency, use MySQL itself. Okay? Do not use Zookeeper in those cases. All right? So thank you, everyone. This was our session on Zookeeper. And okay. So any questions at this point? So the session is not over actually. I would love to answer a few questions, or should we start with another topic? Okay, question from Tegu. Can you repeat about consistency of data? So quick, I'll try to repeat that. Yes, go ahead, Mohsin. So let me answer Tegu's question. Can you repeat about consistency data? Yes, definitely. There was one point that we discussed at earlier. I think it was Mahmood's or somebody from the session. Question was that we talked about leaders and followers. Leaders accept the changes and then distribute it to all the followers, right? Now, by the time the data reaches followers, there could be a slight delay in the changes. Okay, and let's say a person came and wrote data to the leader, and immediately in the next call it is trying to read the data. Let's say the call to read the data went to somebody else, one of the followers, while write data will go to leader. By the time the leader was updating the follower, the client again made a call. So at this point of time, client will feel cheated because client will say that I saved something else and I'm getting something else. What kind of server is this? So data is not strongly consistent. Instead, it is eventually consistent or sequential consistent. Okay. Therefore, therefore, keep in mind not to use Zookeeper when you really, really need strong consistency. Okay, did I make sense to you, Tegu? Okay. Mohsin's question is from the previous session. Go ahead, Mohsin. Okay, Mahmood, I'll answer your question. Question from Mohsin is, when I do Hadoop FS command, then it interact with name node, yes. So on client machine, which config helps host IP address of remote name node? Very good question. So I'll explain to you. On the machine, so we install the Hadoop client gets installed whenever we install Hadoop. So inside etc, there is a command called, there is a file called, there is a folder called Hadoop. Okay. In this, if you go to conf, okay, inside this, there will be okay, HDFS site, right? So in this, we will have the address of the name node. You see here, this is the name node IP address. See that? Line number 214. Okay. Now, second question. Um, in Yarn Node Manager, in Yarn, Node Manager sit on every node. That's right. Node Manager sits on every node. That implies that Yarn program is running on HDFS node. So uh, we try to keep one node manager per machine as well as data node on every machine. Okay. But Yarn knows the address of the name node so that it can communicate and find out which machines are closer to node manager, which data nodes are closer to node manager. Okay, did I answer your question? The second one, in Yarn, node manager sits on the node data node. Yes, that implies Yarn program is running on HDFS node. Okay. So a question is A, B, C, D, E, F are data node on HDFS. All of them are being used running, all of these are running data nodes, yes. Okay, you can take a look at Ambari and the hosts or the services. You will get the clear picture to understand which services are running on which node. Okay, good questions. Okay, very good question. Now, is Ambari installed on all? So Ambari server is installed on A, while Ambari agent is installed on all the machines. Zookeeper client get installed by Ambari itself, and we don't have to do much about it. Okay. Next question is from Nitesh, and I'll answer Mahmood's question soon. Where Zookeeper fits into Hadoop ecosystem? If I have humongous data and I want to do analysis involving Yarn, you don't need to generally touch Zookeeper. Sometimes while during Yarn, when your program is executing on many computers, sometimes you may want a coordination between these programs. You may want to coordinate between these programs only occasionally. All right. Keep in mind that in distributed system, we try to avoid too much of sequential work. Okay, and the moment we have the coordination, things from distributed change into sequential. So we generally like to avoid it, but sometimes it's impossible to avoid the coordination between multiple processes, and those are the cases where we use Zookeeper. Okay, did I make sense to you, Nitesh? Zookeeper gets installed by default when we install Ambari. Actually, I'll show you. Okay, because Zookeeper Everybody else depends on Zookeeper, including HDFS and Yarn and Hive and Kafka. So therefore, Ambari tries to install Zookeeper by itself. Okay. A question from Nitesh. Which fee is taken care by Zookeeper? Okay. So none of the V's. Okay. Neither volume nor velocity. You can some way say that it takes care of the velocity. Okay. Specifically when coordination happens, there's a lot of velocity of requests that come in. That kind of thing is supported by Zookeeper. Okay. Imagine having many thousands of machines, servers, and millions of clients. In those cases, the coordination is taken care by Zookeeper because Zookeeper can handle millions of requests parallelly. Okay. All right. So here it shows that Zookeeper is not active because one of the servers we have forcefully shut down, and that's why Zookeeper on one machine is down. Okay. This machine which generally turn on Saturday, Sundays in morning. Kar, in those cases, you will definitely need HDFS. Zookeeper is just a coordination service. Okay. If you want to store data like 4 terabyte, you would definitely like to go for HDFS. All right. Okay. So, all right. So that's pretty much for today. We will start MapReduce tomorrow. Okay. MapReduce is kind of, you know, we cannot skip MapReduce. Okay, we will try to move little faster, but we really cannot skip it. Okay, the screen only shows off status of different tool, but to get to each tool, you will generally have to go to Hue or Console. Okay, George's question is, I was not able to create the file. Okay, just let me know the screenshot. I'll take a look. Okay, most likely you will be in a wrong directory. If you say cd and enter, you could go to your home directory. You'll be able to create the file. Okay, thank you, Alvin. Thank you, Ravi. Thank you, Rahela. Okay, so I think for Zookeeper, I doubt if we have a quiz. Let me take a look at it. All right, thank you, everyone. So a quiz will come in other sessions as well. Okay, the fourth and third have swapped. Okay, so today was supposed to be, all right, no worries. I'll fix these order and we'll make it such that, all right, wonderful, wonderful to have all of you in the session. Great set of questions. Keep the questions coming and I would look forward to have a discussion tomorrow again. All right, bye-bye, have a great day. Mahmood's question is there any practical lab tutorials that we can follow ourselves on CloudX Lab? So under the learn, I'll show. If you go to CloudX Lab itself, we have put some recordings. So all the recordings are in LMS. I'll update this. Okay. And not this one. I'm sorry. Not this one. I will. Yeah. So if you go to my lab or say learn, so there are quite a few tutorials which we have put in here. Okay. You can take a look there. Everybody will be by default logged in into CloudX Lab if you come to, if you have logged in into. All right. So we have put small videos together so that we all can get started. These are very small, like 1 minute or so. So you can go through that. All right. Bye-bye. Have a great day ahead. Okay. Bye-bye.